So the trapezoidal prisms are going to be just like the triangular prisms, the rectangular prisms, and even like these cylinders. Okay, they're going to have two bases that are identical, that are parallel to each other, and they're just going to be connected. So you just find the area of that base and then multiply by how tall it is, which we're going to call the height. So if we slide down to these, volume equals area of the base, which we're going to call big B, times the height of the three-dimensional shape, which is the distance between those bases, which we're going to call a big H. So first step is going to be replace big B with the right formula. So up here when it was a triangle, we put in 1/2 base times height. Up here when it was a rectangle, we put in base times height. If it was a circle, we'd put in pi r squared. So this is a trapezoid. So we're going to put in the trapezoid formula. So replacing big B, we're still going to have H out here, with the trapezoid formula, which remember is 1/2, another set of parentheses, base 1 plus base 2 times little h. So this can look complicated, a lot of stuff going on, but it's fairly simple. You're going to basically isolate one of these trapezoids and just find the area of it, and then multiply by big H, which is going to be the distance between those bases. So if we look at this picture, there's a lot going on. The trapezoids are the bases because there's one on each side of this shape. It's exactly the same size, and it's parallel. Okay, and then they're just connected. So we talked about in the last video, the top and the bottom are also parallel to each other, but they're not the same size. So we can't call those the bases. The trapezoid here and the trapezoid all the way there in the back, those are the bases. And so they're connected. So this length here, this connection point, it goes from trapezoid to this trapezoid in the back. That's big H, that's the height. How far apart are these two bases? Because you have two bases, and then there's just space between them. So the space between them is the height. Find the area of those two trapezoids, multiply by the distance between them, or the height. So the distance between them is 6. So let's go ahead and replace 6 for right there. Now we got to make sense of all these other numbers. We don't necessarily use all of them, so you got to be careful. Now, again, distance between the two bases is the height of this shape. So picture if I push this over and it sat flat on the base, and then you're measuring how tall it would be. So people want to call this the height, it's 5. But remember, that's diagonal. A height is never diagonal, it's always straight up. So if you push this base over so it's flat on the ground, your height, this 6, would be straight up and down. Now what we want to do is we want to pull this shape out because it's a trapezoid. So we're going to use this formula. But it's kind of hard to see what's going on. So you may need to redraw it. So real quick, let's draw this trapezoid. You've got that long top right there, which we can label as 11. You can see right here. You're going to have these two little sides coming in, which I'm not even going to label because we don't need them. We just need a base 1 and base 2, which is the top and the bottom, and then the height. So the connection down here, this is the other base. It's right here. It's 6. And then we just need a height. So we have a base 1, a base 2, and a height. And that height right here, you can see it's pointing at it. This little dotted line is the height. It's 4.3. So when we plug into this formula, that's all we need. We need the 11 and the 6 is base 1, base 2. So let's go ahead and get these plugged right in. Base 1 and base 2 is 11 plus 6. And then the little height, or the height of this trapezoid, is 4.3. Now there's a lot there, and if you want to cut down on your steps and just add the 11 and the 6 already, and just call this 17, that's fine. Okay, so this is going to become 17. You're going to multiply it times 4.3. You're going to take half of that number, and then you're just going to times by 6. You can do all that in your calculator. Now I wouldn't try and plug all this in with all these parentheses and stuff. You're likely to make a mistake. So just go one step at a time and just keep hitting times equals times equals times equals. So let me run you through with the calculator one time here. To make this easy, I would do 11 plus 6 if I didn't know what it was. Okay, 11 plus 6. And then I'm going to times by 4.3. Hit equals. Take half of that, so either divide by 2, or a lot of you are timesing by 0.5, which is fine. So I added them. Times by 4.3, I took half, and then I just have to times by 6. And I got 219.3. This is yards to the third power. Volume is always to the third power. And just like to the second power, we said yards squared, centimeters squared to the third power is cubed. So this is meters cubed, yards cubed, centimeters cubed. And just like with squared, we could say square feet, square meters. You could switch up the language there, and you can do the same thing here. This could be 60 cubic centimeters, 12 cubic meters, or you could say 12 meters cubed. Either way is fine. They mean the same exact thing. All right, so my big suggestion here is to not try and plug all of this in your calculator at once on your screen and then hit equals. Go one step at a time. Do this, hit equals. Times this, hit equals. Times this, hit equals. Times this, hit equals. You're going to be a lot better off, I think.